at this in detail because this is quite new for the class. So we're looking at sequences and series expansion. Now we want to see, so we want to look at sequences as a function. We also want to look at arithmetic progression. We also want to look at geometric progression. And then also look at the sum of the arithmetic progression and also the sum of the GP, which is the geometric progression. So all these are what we'll be looking at in this course. Now, sequence can also be called progression because when you say something is sequential, you are just simply saying that it moves from a certain step to another step, it moves from one step to another, so it moves at a sequence. So when it is moving at a sequence, we can also say that, or we can also call that process progression. Now, when you look at this example on the slide, you see that we have 2, 4, 6, 8 for the very first 4 terms in this sequence of even positive integers. Now, they are even positive integers because they are positive and then they also are even in nature. So, when we take the sum of the terms in a sequence, we get what we call a series. So, for instance, if we were to add these even integers, positive integers, in this slide, this point here, you will see that when we do an addition of all of them, it becomes a series. But there's something to note, that a series is what you get when you add up all the terms in the sequence. So, if we have this sequence of even positive integers, and then we take an addition of all of them, then this now results from a sequence to a series. So, which is what we have here on this slide. So, where the addition and the resulting value are called the sum or the summation. Now, let's take a look at this example where we have Tn is equal to 3n minus 1, where Tn is the nth term and n is equal to 1, 2, 3 to some infinite value. Now, this gives us a formula for finding any required term. So, however, a sequence, for instance, T1, T2, T3, up to Tn, is the set of images given by the function Tn equals to Fn. Now, let's look at this example. So, they say, for example, we have given the n term of a sequence is given, write down the terms. That's the first terms of first term A, second term A plus B, third term A plus 2D, and then the fourth term A plus 3D. Now, you find out that there is a sequence from this first term right up to the last term, which is the fourth term. You see that there's an addition where it comes in a series 1, 2, 3. So telling you that there's a particular sequence that is going through all this that will result to what we call a series in our example. So now you'll be surprised how we arrived at this. We can say can we say it has answered the question? The answer is no. Now the end term of a sequence of this particular sequence here, when you substitute it into this formula, will be Tn is equal to A plus n minus 1 into D. Now, if we take the first term and assume that n is equal to 1, then it means that when we substitute 1 into n here, and also substitute 1 into n here, we will have T1 is equal to A plus bracket 1 minus 1 D. And now this, when we take the product of 0 by D, it becomes 0, and then we just have T1 as A. Now the next thing to do also again here is to substitute when n is equal to 2. So when n is equal to 2, we have T2 is equal to A plus 2 when we substitute TDN minus 1 into D. So 2 minus 1 into 2 minus 1 will give us 1. Therefore, our T2 is equal to what? A plus D. So this is trying to prove these various terms that are of importance to us here. So you see that T2 is equal to A plus D, which is this second term. Now for the third term, we take N is equal to 3 and substitute, and then we'll arrive at this answer where we'll have A plus 3 2D, which is this, and so on and so forth. So that's what we do in this slide. So where A is the first term and D is the common difference. So if you look at this equation, the common difference here is 1. So 1, the difference between here and here is 1, the difference between 2 and 3 is 1. So that's why we have the common difference. Therefore, the first 4 terms would be this, and this, meaning that we will have A plus A bracket. Please excuse me, we have, this is corrected in the notes, we have A plus D here for A plus 3D. So this will be corrected in the main, it's corrected in the main notes. Now let's look at progression, arithmetic progression. Now, arithmetic sequences are sometimes called arithmetic progression. Now, in an arithmetic sequence, the difference between one term and the next is a constant. In other words, we just add the same value each time to infinity. So for instance, we have these numbers 1, 4, 7, 10, 13, 16, 19, 22, 25. Now, this is a sequence. And if you look at it carefully, you see that the common difference between these numbers is 3. Because when we add 3 to 1, we arrive at 4. Add 3 to 4, we arrive at 7. Add 3 to 10, we arrive at 13. Add 3 to 13, you arrive at 16, and so on and so forth. So the common difference in this sequence is 3. So in general, when we look at the arithmetic sequence that we got from the previous slide, you see that the first term, the second term, the third term, and the fourth term are represented in this formula. That's why you see that if we say the common difference here is 3, it means that when we have the first term as 1, it therefore means that when we add the common difference, which is the D, to 1, you will now get 4. So 1 plus 3 will give you 4, and 1 plus 6, that's 2 into 3 will give you 7, and so on until you arrive at the last answer. So, so you can make the rule for this by having xn is equal to a plus d into n minus 1. Where we use n minus 1 because d is not used in the first term. So that represents the difference, which is the common difference in that particular sequence. So for example, write the rule and calculate the fourth term. So something like this can appear in your exam, where we give you a sequence of numbers and then ask you to calculate the fourth term. So this is very important that you take note of while reading and also while listening to this lecture. Now, you see that when you look at this 3, 8, 13, 18, 23, you see that there is a common difference among them. And that common difference is 5, because when you add 5 to the first term, you get 3. Add you get 8, add 5 again to 8, you get 13, and so on and so forth. So the common difference in this sequence is 5. The values of A and D therefore becomes A, which represents the first term, 3, and then D, the common difference, which is 5 from this sequence represented here. So now, using the rule we stated in this previous slide here, where xn is equal to a plus d to n minus 1, when we apply this rule to this example, you will see that xn will be equals to 3, which is the first term, plus 5, which is the common difference, into n minus 1. Okay, so now we don't know what the value of n is because we are looking to find for the fourth term, so we don't know what the n is. So in this situation, we expand this equation by doing what? By multiplying 5 by n and also multiplying 5 by minus 1. So when you do that, you find out that we will arrive at 3 plus 5n minus 5. Now there is a common factors because 3 is a constant term and 5 is also a constant term. So we take the difference between the two because we have the minus sign here. So 3 minus 5 will give us minus 2 and the 5n still remains the same. Now, to calculate for the fourth term, it therefore means that our xn now becomes 4. So where we are representing 4 as n in this equation of 5n minus 2. So x4 is equals to 5 times 4. So the dot there is representing multiplication sign, not that it is 5.4. But that this dot here, it simply says that 5 is multiplying 4 as a result of the fact that our n here is equals to 4 because we are asked to look for the fourth term. So when you do that, you see that 5 times 4 will give you 20, and then 20 minus 2 will give you 18. So the fourth term in this sequence is 18. So you see that we can prove that when we count term 1, term 2, term 3, and term 4, you see that we have been able to prove that actually 18 is our fourth term by using this formula to calculate. So if we also want to use a different, let's say for instance the question was asking for the sixth term. It means that because it's asking for the sixth term, we will now substitute 6 into n here, meaning that when we multiply 5 by 6, that will give us 30. And when you subtract 30 by 2, you now have 28, representing the sixth term in this sequence. So that's the formula for doing this. So this is important that you know it because it's likely to show again probably in the exam or probably in an assignment. So it's important that you know about arithmetic progression. Now let's look at geometric progression. Now geometric progression is a geometric sequence where each term is found to be multiplying the previous term by a constant. So now that can be represented in this format as a, which is the first term, comma, ar, and then ar raised to the power 2. One thing to notice in this geometric sequence is that there is a power raised to 1 that follows a particular sequence with a difference of 1. So you see that there is a power here 1, there's another power 2, there's another power 3. So if we were to have ar, the next power will be ar raised to the power 4, where a is representing the first term and r is just representing the factor between the terms, which is sometimes called a common ratio. But in the arithmetic progression, it is called a common difference. So in this case, it's called the common ratio. So now we have sequence of numbers 2, 4, 8, 16, 32, 64, and so on. So this sequence has a factor of what? 2 between each number. Yeah, you have a factor of 2 between each number because when you take a factor of these 2, you have 4. A factor of 4, you have 8. Factor of 8, you have 16. Multiply 16 by 2, you have 32. Multiply 32 by 2, you have 64, and so on, up to the last number. So each term, except the first term, is found by multiplying the previous term by 2. That's what we mean. So if you multiply this previous term by 2, you get 4. Multiply the next previous term, which is 4 by 2, you get 8, so on and so forth. So that's how the sequence moves all through to the last number. Then here, we have 1, 2, 4, 8. The sequence starts from 1 and then doubles each time it progresses. So each time it progresses from 1 to 2, it doubles itself again, and this it also doubles itself. So in this sequence, A equals to 1 is represented as the first term, and then the arrow, which is the common ratio, is 2 because each of these terms doubles themselves as they move across the sequence. So now we will get that the first term, which is A, and the second term, which is AR, remember we have used the figures to represent A and R. So it means that when you substitute A here, which is 1 times 2, you will still remain with this 1 times 2. And then in this formula, you say 1 times 2 raised to the power 2 because R here is raised to the power 2. And then 1 times 2 raised to the power 3 because R is raised to the power 3. Now when you dissolve this to the normal, when you break this down, you see that we have 1 and we have 1 times 2, 2. We have 1 times, because this is raised to the power 2, now it becomes 4. So 1 times 4 is 4. This raised to the power 3 means you multiply 3 by itself 3 times to give you 8. So that's how you now come to this sequence by using or applying the formula. So, but one thing to note here is that you must be able to identify what your common ratio is for you to arrive at this final answer. So now, so there's a rule here that says R should never be 0, because when R is 0, then this sequence becomes 0 all through, which will not be geometric anymore in nature. So the rule, you can also calculate any term using Sn raised to the power ARn n minus 1. So which is what we did similarly to the arithmetic progression. So we have another progression here, a sequence here, where we have 10, 30, 90, 270, 810, 2030. Then this sequence has a factor of 3 between each number. So you see that if you multiply 10 by 3, you have 30. Multiply 3 by 30, you have 90, and so on. So the first term here is 10. Now we want to look at the common ratio. And the common ratio here is represented as what? 3. Because when you raise any of this to the power 3, you see that you arrive at the answer. Because the common ratio here is 3 when you multiply 3 by its previous value. So if we were to substitute that previous equation on this formula, you find out that we have the first term as A equals to 10, where you now have Xn is equals to 10 times what? 3 raised to the power n minus 1, where if we were to calculate the fourth term, then our n becomes 4. So meaning that we will have x4 is equals to 10 times 3 raised to the power 4 minus 1. So when you do that, you see that this raised to the power 3 means that we are multiplying 3 by itself 3 times, which is 27. Then times 27 by 10, it will give you 270. So when you calculate in this sequence, you see that the fourth term is 270. So we have been able to prove that this fourth term is 270. So it's also important to know this, because when you are asked in the exam to use this sequence and calculate the fourth term, you should be able to arrive at this answer after calculation. Now, if we were to look at the 10th term, though the 10th term is not represented in this sequence, but if we were to continue to expand this sequence to get to the 10th term, you will find out that our resulting answer will be 106,830 when you calculate the geometric progression. So this is a formula for the sum of an arithmetic progression. So AP is just arithmetic progression, that's the full meaning. So where the formula is given as Sn is equals to n, and where 2 into 2a plus n minus 1 into d is the formula. So where they say here Sn is equals to what? The sum of an arithmetic progression. Now A represents the first term, N represents number of 10, and then D represents the common difference. So find the sum of the first 20 terms of 258. So here, there's also a common ratio of 3, or a common difference of 3, where A is equal to 2, and the common difference D is 3, and then the question is saying 20 terms. So 20 terms means that our N will be equal to 20. So if you took that in this formula, you arrive at this tenth, the 20th term being 610 in value. So that's how to calculate the arithmetic, the sum of an arithmetic progression. Then the sum of a geometric progression is represented by this formula, where we have Sn is equal to A into 1 minus Rn all over 1 minus R. So this is when R is less than 1. Because when R is equal to 1, then this progression becomes 0, which will not hold. So the rule here is that you make sure that your R is less than 1 for the progression to be okay. So here we also have to another rule that this only applies when R is greater than 1, when you must have moved the sequence around. So the sum, find the sum of the first 10 terms of 1, 2, 1, 1, 1, and so on. You see that the first term here is 1, okay, and then we have R is equal to what? 4 divided by 8, which is equal to 1. 4 times 1, which is equal to 2, where N is equal to 10. So when you substitute in that formula, we arrive at 8 as the answer. So that's that for arithmetic progression.